Atomic structure day 2. How do we use table O to determine the 3 subatomic particles of an atom? So guys, over here there is a picture of an atom which has the positively charged protons. Okay, right here. And it has the zero charged neutrons right there. All right, outside, remember they're flying around the speed of light, are the negatively charged electrons, which are going round and round, different orbits around here, okay? Okay, let's move on. Subatomic particles, table O. So remember I said to you over here in class that the subatomic particles of an atom, there are 3 that we need to know so far. Proton. Well, if we go to our table O, we're going to see this notation here, these 2 notations, 11H or 11P. So basically over here, we learn that the top number is the atomic mass. The bottom number is the atomic number or charge. Okay? So if you look over here, look how nice this is. They gave us 2 of the 3 most important things here. The atomic mass says 1 AMU. Well, that's what the mass is. It's on top. All right? The charge is located on the bottom here. That's +1. Okay? So that is your charge or atomic number there. Okay, which is 1, but it's understood as +1. The only thing you need to know is where it's located. It's located inside the nucleus. So here's your nucleus here. All right? The nucleus contains what's called the atomic number, which are the protons. The next subatomic particle that's in the nucleus of any atom are neutrons. So here's your neutron. On table O, you're going to see the notation here of 10N. So again, the top number represents the mass. So the mass is 1 AMU, which is right there. Oh, I apologize. Is right there, 1 AMU. And it tells you right here, that's the mass. So you don't need to memorize on table O. The bottom number is the charge. The charge here, this time for a neutron, is 0. Because the word neutral means simply 0 charge. Again, the only thing you need to memorize, guys, is where it's located. It's located inside the nucleus. So again, which 2 particles make up the nucleus? Well, they're the protons plus the neutrons make up the nucleus. So we said, remember, protons and neutrons are inside the nucleus. The only subatomic particle that's located outside the nucleus is the electron. Well, if we go to table P here, table O, the electron says there beta particle. So it's not going to see the word electron there. You're going to see the word beta particle. It means the same thing. Okay? So now it asks you what's the mass? Well, it tells you the mass is 0. We know that because if you look at the top here, the mass is 0. The charge is located on the bottom, or atomic number here. In this case, the charge. The charge is -1 for electrons. Now, if you notice, they say E or B because they're the same thing. The only thing you need to memorize is the location. It's located inside the nucleus. Okay, let's move on. Next slide. Solvent for protons, electrons, and neutrons. All right? So look over here. This is very important. Whenever you see a question that has the word atoms, atoms means electrically neutral. That means we have an equal number of protons, which are positive. Protons are positive. And electrons, which are negative. Okay? So let's determine the number of protons, electrons, and neutrons in these atoms here. Well, let's look at the picture on the left. It says carbon, which is C. The mass is 13. The atomic number is 6. So what I want you to write down first is write down the number of protons, neutrons, and electrons. Guys, electrons, if you notice, I have this negative charge there because on the Regents exam, you need to write the negative charge or you're going to be marked incorrect. So you have to write E negative for electrons. Okay, so let's go over what it says here. What are the number of protons, neutrons, and electrons? Well, we learned that the protons are the atomic number. So if the atomic number is 6 protons. If the atomic number, well, the number of protons equals the number of electrons in an atom, 6 electrons. Now, to get the number of neutrons, all you simply have to do here is to subtract 13 minus 6. Well, 13 minus 6 gives me 7 neutrons here. Okay, hit pause and try this next one yourself. Okay, we're back. Proton, neutrons, electrons, E negative. Okay, again, how many protons are here? Well, the atomic number, which is the bottom number, tells you number of protons. So it's 15 protons. In any atom, the number of protons equals the number of electrons, 15. And again, to get the number of neutrons, you simply subtract the mass minus the number. So 31 minus 15 will give us 16 neutrons. Okay, let's move on. Next slide. Atomic number or nuclear charge. So now, the atomic number and nuclear charge is simply here the same thing. Atomic number and nuclear charge, all right? So if they ask you what is the atomic number or the nuclear charge, it's simply the number of protons or bottom number. Now, if you notice over here, I did not include the mass. If you want to find the mass, you go on your periodic table. The mass of Mg says 24.305. Now, all you need to do is to simply round off 24.305. So if you round off 24.305 to the nearest whole number, that will be 24. Okay? Again, you need to look that up yourself. So now, we said protons is P. How many protons are here? Well, there are 12. So write 12 there. How many electrons are here? Well, in an atom, all atoms are electrically neutral. So if I have 12 protons, I will have 12 electrons. And again, to calculate the number of neutrons, you simply subtract 24 minus 12 will give me 12 neutrons. So let's put a 12 there. Okay, hit pause and do this one yourself after I give you the mass, okay? I mean, you can look at the mass. The mass will be 35. I'll give it to you now. Okay, but now you go to your periodic table and round it off. So, the number of protons here is 17. The number of electrons here are 17. You subtract to get neutrons, and that will give us 18 neutrons. Okay, let's get rid of this slide here. Move on. Atomic mass. Let's take a picture so I can add it. The atomic mass here says over here, if I say atomic mass, mass number, or nucleons, that means the same thing. It's the mass of an element's naturally occurring isotopes. We'll get into isotopes on the next day's slide. Basically, there's more than one type of each element. For most elements, not all, except the radioactive ones. We'll go over down the road. All right? Now, what you need to know here is that which two particles make up the mass? Well, if you go to the table below, we said before the mass of a proton is 1 AMU. The mass of a neutron is also 1 AMU. Okay? So, but we said the mass of an electron is 0. So electrons have nothing to do with the atomic mass of an element. The only two particles that matter are the protons and the neutrons. Let's look at the question below here. Let's look at this question here. Okay? It says, what is the mass number, or hence atomic mass, of an atom, as we said, are electrically neutral? That has 6 protons, 6 electrons, 8 neutrons. Okay, I'm going to hit pause, and I'd like you to answer this question yourself. Okay, we're back. So, What matters here is the number of protons, which is 6, plus, that's right, 6 protons, plus 8 neutrons. Again, electrons do not have a mass. So what's 6 plus 8? Well, 6 plus 8 will give me 14. Now let's go on top to the example here I'd like to show you here. I'm going to erase this part here so you see what I'm talking about a little better. Now, there are 2 ways to write the mass of an element. One way is simply put the number on top, like over here, C14. Another way is write, you see how this one says C-14? It's not minus, it's dash. You simply put the 14 on top. Okay, that is the mass. Okay, it is the same as this over here. They're both the same. So there's 2 ways to write the mass. C with a 14 on top, or C-14, which means the same thing. The only thing that's not there is the atomic number, which you look up yourself on the periodic table. The bottom number, that's bold, that would be 6 for carbon. Okay, let's move on. There are Regents questions here to be done. Which 2 particles each have a mass approximately to 1 atomic mass unit? Again, guys, when we go to our table O, all you have to do here is simply look up the masses of each element. Okay, so the mass, let's take a screenshot. The mass here of a electron, we said was 0. Neutron is 1. That's no good. Electrons don't count. Electrons don't have a mass. So anytime you see something with electron, that's out. The only 2 particles that make up the mass, we said, are protons and neutrons. That would be the answer there. Okay, hit pause and do the next questions yourself. Okay. An atom is electrically neutral because what did we say before? Which 2 particles make it neutral or 0 charge? Well, you need the same number as positives as you do as negatives. So the number of protons equals the number of electrons because atoms are electrically neutral. Okay, let's look at the top right question here. A proton, remember, if you look on the table O, is positive 1 charge. Has a charge that is opposite the charge of? That's right, electron, which is negative 1, so it's choice 3. Number 4, which group of models is listed in historical order from the earliest to the most recent? Well, guys, we learned 4 models. The first model was Dalton, which was the hard sphere. So automatically 3 and 4 are gone. Hard spheres first. Then came J.J. Thomson, who discovered the electron using the plum pudding model. But guys, if you notice over here, I don't see J.J. Thomson's model here, the plum pudding. So they just totally bypassed it. Then came the Rutherford's Goldfield experiment, okay, which is the electron shell model. And then the last one was the wave mechanical, which is the modern model. So that is your answer. Okay, I'm going to click done. Let's go to the last screen of questions. This is part 2 questions that are found in the Regents here. All right, I'm going to take a screenshot and let's answer these questions together. Okay, first, if you can do it yourself, I suggest you try to do it yourself, and then I'm going to go over it. Here we go. The diagram below represents 4 atomic nuclei. Nucleus 1, 2, 3, 4. Now look at the key. The key tells you the black dot is the proton. The white dot is the neutron. Okay, so that's important, all right? Number 54, identify the element that's the atomic nuclei represented by nucleus 1. Okay, let's go to nucleus 1, guys. So the element from nucleus 1. Well, remember I said what tells us the element is the atomic number. The atomic number is simply the number of protons, okay, or black dots in this case. So we need to count the black dots here. 1, 2, 3, 4, 5, 6, 7, 8, 9 dots here. So 9 means the atomic number is 9. So you need to go to your periodic table and look up the atomic number of 9. Okay, so hit pause and do that right now. Okay, we're back. Well, if you look it up, fluorine has an atomic number of 9, so that would be your answer. symbol F. Okay, let's go on number 2. Number 2 says over here, determine the mass number. Mass number or atomic mass or nucleon is the same thing. Represented by nucleus 2. Okay, so I'm going to erase this over here. So let's go to nucleus 2, guys. All right, here's nucleus 2. Well, first of all, we said the mass number are the protons plus the neutrons. Okay? So that means we need to count all the circles in here, the white and the black, because that represents both protons and neutrons. Let's go. Let's do it right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 particles there. So the mass number would simply be 18. Okay, 56. Explain why nucleus 2 and nucleus 4 represent nuclei of two different types of isotopes of the same element. Okay, this was actually in lesson 3, day 3 is atomic day 3, but let's go over it now. So we learned that an isotope are elements that contain same protons, different neutrons. So if you counted them up, they would both contain the same black dots, which are the protons. Okay? Same protons. You can go there and count up the dots. I'll count it with you, nucleus 4. Nucleus 4. 1, 2, 3, 4, 5, 6. Okay, let's move on. 7, 8. And it says nucleus 2, right? Okay, so nucleus 2. Let me erase what's here, guys. Hold on a second. 1, 2, 3, 4, 5, 6, 7, 8. So obviously they have the same protons. 57 says identify the nucleus above that is found in and that is a stable valence electron configuration. Okay, you haven't learned that yet. But so let's just not even do that one now. Okay, I'm gonna click done.